Welcome back to our short course on the principles of data visualization. So far, we have seen that the visualization is a necessary tool for us to better discriminate and differentiate between different data sets. We also have seen that some features are automatically perceived without the need of focused attention, and also some features help us to organize, cluster, and characterize the visuals. And now, in this last part, we are going to have a look at graphs and tables and discuss how we can better plan and design them so that they have a better visual appeal. Let's have a look at some guidelines to design tables and graphs. First, let's get to know some concepts related with tables. Here we have a standard table with the table caption. It's important to note that in most computer science and engineering literature, you find the table caption above the table and the graph caption under the graph. This varies depending on the discipline, but in computer science and engineering, that's usually what you're going to find. In this table, we have this line here at the bottom that we call a rule or a line. Then we have the line at the top and also the line dividing the headers of the table. These are the so-called column headers. And we also have the grid, which is composed of the lines that divide the cells of the table. And we also have the table borders. So these are the main components of a table. The first thing that we need to understand is when should we use tables or when should we use graphs? Tables are usually employed when we want to show specific values and we want to show those values with precision, because the tables allow you to insert or to input the numerical value representing a given variable. Whilst in graphs, you usually plot the graphs and the axis, but the axis only give you an approximate view of the real value that is plotted in the graph. You also use tables when you want to compare pairs of values for different variables, because tables are composed of columns and each column represents one different variable. So in a single row, you can compare many different variables, including variables that span over different domains or over different ranges. And this is very relevant because when you plot a graph, you usually have a single range in an axis, but in the table, you have many columns and each column can have its own range or its own domain. So the general comparison or the general lookup can be performed in a table. Also, when objects must be compared over various characteristics with different units of measure, just as I said, and when a single display must be used to present unit and summary data. Analogously, let's have a look at some characteristics of graphs. Here we have the graph caption under the graph, and we have the axis, the x-axis and the y-axis. Then we have the y-axis labels, the x-axis labels, the x-axis title, the y-axis title. We can also have the graph title here above the graph, and we can also have a legend. As we will see, sometimes instead of adding the legend here, we can simply add the legend next to each of the curves that we present in the graphs. And when to use graphs? We use graphs mainly when a set of quantitative values must be examined to find their general shape, pattern, or trend. So that's a big difference between graphs and tables, because tables allow you to compare different values with precision, and graphs allow you to look and to find trends, to find specific patterns in the data. Also, graphs are much more useful when you have a large amount of data that you cannot show in a table, but you can summarize them or you can depict them in one single graph. And as I mentioned, as we have the axis, we must have the same unit for all variables that we are going to plot in the graph. In some cases, one thing that we see sometimes is that we use a different unit in the right-hand side of the graph and another one in the left-hand side of the graph. And then you can have curves that are read in the different sides of the graph, each one with its own unit. But this is not something very ordinary or very commonly found in the literature. This table shows a trade-off between tables and graphs. For example, the tables, they privilege accuracy in identifying values, while the graphs do not give you this accuracy. The easier identification of trends in data we have in graphs instead of tables. When we want to do direct comparisons, then we'd better use tables instead of graphs. When we want to compare over multiple characteristics simultaneously, we also use tables instead of graphs. And when we want to display unit and summary information, tables are also more suitable than graphs. In the other cases, when we have large volumes of data and when we want to quickly identify patterns, trends, and outliers, so we'd better resort to graphs. Our next step is to discuss some guidelines to visualize or to design tables. First thing, use lines only as table frames and to separate the title row or the table headers. Usually, if we use one line between each row in our table and one line between each column in our table, we are going to have that table within a grid that in many cases are very heavy or cluttered with information. Then, offset the headers from body. How can you do that? You can, for example, use one line to separate the header from the body of the table, or you can use, for example, boldface letters or italics for the headers of the table. If you want to divide the cells of the table, use subtle dividers instead of using heavy grid lines. Again, this is to avoid that grid perspective of the table that in many cases you don't want. You want a more elegant, a cleaner table instead of that table full of lines within its whole body. Another important issue is to right align numbers. And the reason why we should right align numbers is because if we standardize the number of decimal places that we have in the numbers, then by right aligning them, we allow a direct comparison between values within the cells of the tables. If you, by contrast, either center or align the numbers on the left, it will be much more difficult for you to do a direct comparison of the magnitude between the different numbers in the table. By contrast, you should left align text, and the reason is because we read from left to right. So if you left align the text, then you have a natural order of reading the text within your table. And if you have columns with a single character or with the same number of characters in each column, you can center align them. This is because this will allow you to more easily compare and find the differences between the values in each cell of the table. For example, if you have T representing true and F representing false for a given variable, you can center align the values of this variable such that you can easily read that variable, that column, and see the difference between the values. In relation to the headers, they should be aligned with the data. So if I have text aligned to the left, then my header should be aligned to the left. If I have a variable that is centered, my header should be centered. And if I have a variable that is right aligned, for example, a numeric variable, then I should right align my header as well. It's also important to select the appropriate level of precision. If I want 1 decimal place, 2 decimal places, or whatever, I should just select it appropriately based on my analysis and use the same standard level of precision for all values in my table. It's very important to keep enough space between rows and between columns such that you can guide the reader in relation to where I finish one column or one row and I start another. You should also avoid repeating specific units. For example, temperature in Fahrenheit or Celsius, or currency units, for example, US dollar. You don't need to repeat this unit in every cell of the table. You can present the unit in the header of that specific column, and then you just present the numbers in each of the cells. If there are values that you want to highlight, for example, a maximal value, a minimal value, an average, or an outlier, you can highlight it in the cell. You can, for example, boldface the value, or you can paint the cell using gray color or using any color that you want. You can use different colors to represent different types of values. For example, you can use a green value to represent a good result, a red value to represent a poor or a bad result. All these are techniques that help you to present the information, to present the data within tables. And finally, you can group similar data and detach them in a given table. You can group, for example, based on performance, based on region, based on size, based on weight, based on any specific category that you can use to separate your data among each other. To illustrate, let's see 3 different versions of this table. This table is a sample of the Natural Earth dataset, whose link you can find in the description here. And it's showing us 6 variables: the estimated size of the population, the continent, the name of the country, the ISO or ISO A3, the GDP, and the geometry. The geometry here refers to a general shape of the country. In this case, we are showing either a multi-polygon or a polygon here for the geometry. This is a pretty much standard version of the table, with all the lines forming the grid of the table here, everything centered. We have the numbers centered. We have all the nominal variables of continent, name. This is a code, but still it's a nominal variable. This is another numerical variable. This is another nominal variable. Everything centered. In the second version, we have already applied many of the guidelines that we presented. First, we align all numbers to the right. So we have the estimated population aligned to the right. We also have the GDP aligned to the right. We also have the nominal variables or the text variables aligned to the left. And we also align the variable ISO to the left and the variable geometry to the left. And we remove the grid lines, maintaining only the frame lines here and including the line dividing the header. We also boldface the headers. And we have the third and final version of this table, in which we grouped the variable continent, and we also moved the order of some variables. Here we had the variable pop est first, then continent, and then name. And in the third version, we have variable continent first, then variable name, and we moved variable pop est to the third column of the table. In this slide, we compare the 3 versions, and as we can see, there is a great gain in terms of readability and in terms of elegance when you compare the first version with the second one, and finally with the third one. I could also, one thing that I usually do is I would center the name of these categories here in each of the set of rows in which this category is inserted. So Africa would be here in this row, America would be in between these 2 rows, and Europe would be aligned here with this row at the middle. Let us now have a look at some guidelines to display graphs. First thing is show the data. Focus on those values, on that information that you want to detach and that you want to display in your graph. And this means reduce the clutter. That is, any information that is not really necessary, that you don't want to detach, to stress in your graph, it can be removed. Focus on the data and the information that you want to convey in the message, in the story that you're going to tell with your data. In many cases, it's also important to integrate graphs and text. For example, instead of using a separate legend, you can include the legend in the graph itself. Try and avoid what we call the spaghetti chart. And this spaghetti chart is the one that has an excessive amount of colors, icons, bars, texture. There is just so much information in the graph that you don't allow your reader to grasp what you really want him or her to grasp from the graph. And finally, if you are unsure about which color to use, start with gray or start with one pale color, one more monotone color that you can play with, and then you can start trying different colors in your graph. To illustrate the guidelines to design graphs, I generated 3 versions of the same set of curves here. I'm plotting the sepal length versus the petal length of the iris dataset of Fisher. In this first version, I am plotting the 3 plant species using the same color, which is a gray color, and different line textures. And also, I'm using a separate legend here. In the second version, I'm using the same type of line, which is a continuous line, and I am also plotting the legend next to each of the curves. And finally, in the third version, I have a different color and a different texture for each of the curves. This way, you can observe the impact of each of these pre-attentive features in the final result of your graph. Thank you for watching, and don't forget to have a look at the other courses and series that we have in our channel.